Hello, viewers. Good evening, everyone. I may not know which part of the country you are watching from, but it's just a little quick wit that was sent across to me by my students, and thought it's wise I share it with everybody because, especially for students um, who will be writing the upcoming jam that is this year. That is joint admission matriculation examination that will be taking place. So these aspects of chemistry is something that is physical, something you can look at it and analyze, catalyze, and also have the ability to interpret questions based on guiding principles that have been laid down by a UPAC system of naming. As such, this question most at time look confusing to students because of the way JAM always put the question. Lastly, most at time JAM tend to give they don't tend to give the structural representation of organic compounds. They place them in condensed form. By condensed form, they write it not in structural form. I want to see how students can interpret the condensed formula into structures and give the naming from the options. So most times students find it worrisome to interpret. For today, I wouldn't be talking about the condensed aspect of it, but in my next video, I will come up with some condensed forms of organic compounds, and I will also give the IUPAC interpretation to it. I will be able to strip it off the mystic that lies on that particular questions. But for today, let us analyze these questions that these students sent across to me. I don't know. I have been able to draw it on this paper for you to see. It is a six-membered ring, a six uh, membered hydrocarbons, as you can see from the paper. But basically, I can turn the video so that you can see it properly. Let me keep it well. Now, if you look at it from these aspects, if you look at it, you can actually understand and you can see how the structural formula of this compound. The student actually is confused on how to assign priority to this system of naming. But first, looking at the structure which I have shown you previously, the first thing which you have to do is to the first thing which you have to do is to remember your first rule in organic chemistry, which says I will locate the longest possible continuous chain, note the word continuous, longest possible continuous chain, and make it my parent hydrocarbon. So once you are able to locate the longest continuous chain and make it your parent hydrocarbon. Now, if you look at that structure that I've just shown you recently, you will agree with me that at this point you are noticing there is a double bond. Irrespective of the haloid group that have been attached, the chlorine that have been attached to it, and you also notice the methyl group have also been attached to the chain. So the first thing which you need to do, I will first and foremost point out the possible mistake that students will make if they want to name this compound. Let's go back to the structure. Now, the first mistake students will make, if you look at it, they will make that mistake of saying that the longest possible continuous chain contains 5 carbon atoms. That is, they will start their numbering just the way I have did. They will number first carbon atom, second, the third one, the fourth, and the fifth. They will stop at the fifth. They will be taking the 6 carbon atom as an attachment. Of course, it can confuse anybody, but take note of the rule that says I will locate the longest possible continuous chain and I will do what? Make it my parent hydrocarbon. Now, if you look at this, the parent hydrocarbon is the hexene. Because of this double bond, is the hexene. So I will start my numbering at the side that will give the double bond the least number of priority. Now, if you look at this, if you start from where you're having number 6, 1, 2, 3, 4, 5, that means you will be giving this double bond priority number 4, and it will be wrong. So the correct system of numbering is starting from here. So you have carbon atom 1, 2, 3, 4, 5, and 6. So in this particular chain, there are 6 carbon atoms, longest carbon atom. The only attachment you're having 1, 2 attachment. That is, you're having 2 methyl group on carbon atom number 4 and 2 chloro group on carbon atom 2 and 3. So at this point, we are having methyl group and chloro group being attached to this system. How will you name it? The rule says, in a system of where you are having different functional group, different attachment, alkyl group, you're having an alkyl group and also having a chloro group being attached to it, the naming should follow in alphabetical representation. You can see this CH3 is a methyl group M, and that M, as you have seen, C comes before M in the arrangement of letters of the alphabet. So the naming, chloro will be named first after you mention the position of the methyl group also, the two of them, before you include different compounds. So coming back to this, we will follow the system of naming by starting from the side that give this attachment the least number of priority. If you can see it with me, I don't know how I can place it better, but if you can look at it, try and picture it. So you will notice that at this point, carbon atom 1, 2, 3, 4, 5, 6. That is 6 carbon atom. So the name will comes 1, 2, 2, 2. Sorry, 2, 3, because there are 2 chloro compound attached as carbon atom number 2 and carbon atom number 3. So it's 2, 3, di, because there are 2 of the chloro compound being attached. Dichloro, we now move towards this one, carbon atom number 4. 4, 4, the 4 you mentioned, because there are 2 of them attached as carbon atom number 4, you mentioned 4, 4, dimethyl, hex. The position of the double bond, hex. The position of the double bond is at 1, 2, 3, carbon atom number 1, 2. So you're having a carbon atom number 3. Carbon atom number 1 is carbon atom number 1, number 2, carbon atom number 3, carbon atom number 4, carbon atom number 3. So between 2 and 3, so the name now goes 2, 3, dichloro, 4, 4, dimethyl, hex, 3 in, hex, 3 in, hex 3 in, which simply tells you that the carbon atom is attached, the double bond is attached to carbon atom number 3. Most times in an advanced level, you can mention the 2 position by saying 2, 3, dichloro, 4, 4, dimethyl, hex 2, 3 in, to tell you that the double bond is between carbon atom number 2 and carbon atom number 3. Now, the next thing is how you can write the naming, that particular name. So the name is 2, 3 hyphen dichloro, 4 hyphen dimethyl, hex 3 in, ENE. So if I can show you how the naming goes, you can basically see it with me. Look at the name in there. Look at the name in there. Have you seen that? Look at it. 2, 3, dichloro. Look at the comma in between the 4. Very important in the system of naming. Hex 3 in. So that is the IUPAC nomenclature of that particular compound. Thank you. Do well to um, do well to subscribe to the channel by clicking on the subscription button, and also um, share. Next time I will be explaining organic chemistry based on condensed representation. You can also drop your comments and possible contribution for modification of this class. Thank you very much. See you. Bye. So I just got a message by a friend. A person sent me a message um, saying I should see how I can bring up more examples on organic system of naming. I would say by next class I'm gonna come up with numerous ones, and maybe practically I can see how I can make it more easy for people to understand. But anytime you are faced with organic system of naming, you must try as much as possible to look at the naming based on the first rules. I will locate the longest possible continuous chain. Continuous, very important. That word is English word is very, very important. Longest possible continuous chain and make it my parent's hydrocarbon. Once you have been able to align and understand which one is your parent's hydrocarbon, you are good to go. You will be able to um, you will be able to answer the question, because that is uh, the first stage. Identify the longest possible continuous chain. Once you are done with identification of the longest possible continuous chain, the next thing is for you to begin to look at how the attachments, which of the attachments are you having, which side are you having saturated, saturated in terms of many attachments have been attached. In case where you're having more attachments on one side, and in the absence of any major functional group like the double bond, the triple bond, or the OH or the carboxylic functional group at that point in time. If it is only straight chain alkanes, at that point in time, you will pay attention to the functional group that is highly electronegative in the chain. From then you assign priority, making sure that one have a least number of priority. All of these things will be highlighted and explanation will be given. Thank you very much. I don't know whether that my student is online, whether she understood what I have explained to her. If you still have a problem with this question, you can also send it to my mailbox, and I'll be able to, I will see how I can give more explanation. Any aspects of it that you don't understand, please, you can do well to let me know, okay?